Hi guys, and welcome to today's overview of factorising algebraic expressions. So today we're going to be talking about expanding. When we are expanding an expression, we are moving to an expression without brackets. Hang on a minute, what's this term I keep using here? Expression. An expression looks like this. It could be anything. It can be something as simple as 4x plus 3. I've put the brackets around it because I'm going to multiply that expression by 2. It's still an expression. In fact, it's an expression until I put an equals something. Okay? Today we're just talking about expressions. We're not talking about equations. This is an equation. When I take out the equals and the box, it becomes an expression. So I will put here an arrow that shows us what we're moving to. When we are expanding, we multiply the terms outside the brackets by the terms inside the brackets. And from our last video, you'll remember that that is called the distributive law. We multiply the 2 across both terms inside the brackets so that we end up with 2 times 4x is 8x and 2 times 3 is 6. That what we just did there is an expansion. But today we're going to be talking about going the other way. So today we are working this way. We're moving from an expression that has no brackets, like this one here on our right, like this one, and we want to make an expression without brackets. Okay, so now we're talking about factorising. This means we're moving from an expression that looks like this to an expression that looks like this, where we pull the 2 out. Okay, the highest common factor, and move to 4x plus 3. Okay, that's where we're going today. So here is another way of thinking about it. Here we have our expression 2 times 4x plus 3. And on the other side, we have our expression 8x plus 6. How do we get from the left-hand side to the right-hand side? To move from left to right, we need to expand our brackets. Okay? That means we need to multiply. And what does it mean when we multiply? It means we use the distributive law, which works by doing it like this: 2 times 4 and 2 times 3. And then we end up with 8x plus 6. Okay, what if we want to go from right to left? Remembering that right to left is the subject of today. That means we are factorising. To move from right to left, we need to factorise. Okay, that is what we're doing today. And we do this by dividing. Dividing always sounds awful, but really it's simply about finding the highest common factor, or the HCF. This is a great little diagram that might help you to remember what the difference between expanding and factorising is, and the process you use to get from left to right or right to left. You can pause the video and write it down in your notes if you like. But what about factorising expressions? The main purpose of today's video. In the same way, we need to look at the complete expression and look for a common factor across both terms. So this term and this term. Let's look at our first example here. We've got 5x plus 20. This one, we're moving from an expression to a factorised expression. Without brackets here to with brackets over here. Let's have a think about it. We've got a 5 and a 20. Well, the common factor of 5x is 5, and the common factor here with 20, that is also a common factor with the 5x, is 5. 5 times 4 is 20. So we pull our 5 outside of some brackets, and inside we have 5 times x, and we add 4. And lo and behold, if I were to check my answer, I would say 5x, 5 times 4 is 20, which is correct. Let's look at our next example. In our next example, we have 4x minus 16. In this case, we're looking for a common factor between 4x and 16. Well, 4 is a factor here and a factor here, as 4 times 4 is 16. Let's see what happens. We want an expression with brackets. We pull out a 4, and we're left with x minus 4. Don't forget to pay attention to what's going on with your signs. It's very important to get the signs correct. So let's have a think. If we were to go the other way and we were going to check our answer, we have 4 times x. 4 times minus 4 is minus 16. Let's look here at our first expression to factorise. Here we can see we have an expression. Let's have a look at this first term here, 3x squared. Okay, so 3x squared looks like 3x times x. Okay, and that equals 3x squared. We also have 9, which is equal to 3 times 3. So looking here and here, our common factor is 3. That means that our 3 needs to come outside of the brackets. Inside the brackets, we have an x squared and we have a 3. So we have x squared and a 3. But what sign do we put in here? We have a plus 9 here. That plus comes with that number here over to in the middle, because 9 equals 3 times 3. It's a plus here, a plus and a plus here. Here is our expression. Testing using the distribution law. If we've got it right, we have 3x squared plus 9. Correct. Now let's look at this second example here. This example is different because it has an x squared and an x here in the second term, which is something we just can take care of quite simply by following a similar method to that shown above. What we can do here is, let's look at our first term, 2x squared. 2x squared equals 2x times x. 14x equals 2x times 7. Our common factor is 2x. It's also important to note that we've got a minus 14x. That means I should include a minus down here with my 14x, which is just there. That also means that we have 2x times minus 7. We have our common factor of 2x, so that can live outside of the brackets. Inside the brackets, we have an x and a minus 7. X minus 7. Let's check our answer using the distributive law. 2x times x and 2x times minus 7 equals 2x squared. 2x times minus 7 equals minus 14x. This is correct. It matches our original expression. I hope you found this brief tutorial helpful, and we'll see you next time.